Hi guys, welcome back. Today we are going to be talking about parabolas and quadratic equations, and we're actually going to spend 2 days on this. And I know you're probably thinking to yourself, we've been working with parabolas and quadratics for a while now, Miss Baumgartner, you're crazy. But we are actually going to dive a little bit deeper and do something new with this. So if you guys could open your springboard book to page 160 and 161, that's where we're going to be, and you'll need a pen or a pencil. Okay. And what we're basically going to be doing is writing the general equation of a parabola in y equals form using key features. Okay, so this is a little bit different than what we've seen before. Oops. All right, so I know we talked a little bit about this in class, and today we're going to focus on really this here. So vertical axis of symmetry, meaning it's going to be a y equals equation. And then tomorrow we'll focus on horizontal axis of symmetry, meaning it'll be an x equals. Okay, so we already knew from vertex form that h comma k is your vertex. We're going to talk more about what a focus is and what a directrix is today, because those two pieces of information will help us to write a quadratic equation in vertex form. Okay, so let's go ahead and get started. And on page 161, there are these 5 examples. We're going to do just these 3 today, and then we'll do 2 tomorrow in the video. But this is super important. You need to draw a picture for each because that is really going to help you. Okay, and I'm going to do that as well. And I'm just going to split these up onto other pages so I have room to draw my picture. Okay. So this first one, it says the directions were to use the given information to write the equation of each parabola. Okay. So we are given the information of the vertex and the focus. Okay. So I'm going to first draw my picture. And I need to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's go up a little bit more. 6, 7. Oops. Okay, so I know I have the vertex at 3, 4, so I'm going to plot that point. And maybe you even want to kind of label it vertex, okay? And then I know I have my focus at 3, 6, so that's up here. Okay, so that's your focus. So a couple key pieces of information that we talked about in class is that your parabola is always going to open towards the focus. So now we kind of know that our parabola, and we're just doing a quick sketch, we don't know many more points, but we know it has to open up because it always has to open towards the focus, okay, and away from the directrix, but we'll talk about that more in a minute. Okay, so now we know what this picture looks like. And then remember, we talked a little bit about what this p value does. Okay, and the p is the distance from the vertex to the focus or the vertex to the directrix. Well, in this case, we only have this distance here from the vertex to the focus. And we know that that is 2 away, right? Because it goes from 3, 4 at the vertex to 3, 6 at the focus. Okay, so we know that that P distance is 2. Okay, so now we really have all of the pieces of information that we need. We know where the vertex is. We know the distance from the vertex to the focus. So we're going to plug those into our equation. So we have y equals, and we're using this equation here, because it opens up, so it has a vertical axis of symmetry. So that's what we're focusing on today. We're only going to look at vertical, okay? So y equals, and we're going to write this as 1 over 4p, but remember our p is 2, so let's plug that in. And then times x minus, okay, so now here's where we need to plug in our hk, which is our vertex. So our h is going to be 3. And remember, minus 3 means to the right 3, so that's good. And then we want to put up 4 or plus 4 because that's where our vertex is. So then we just need to simplify, and this would be the 4 times 2 is going to be 8, so 1/8. Oops, I forgot my squared there. Times x minus 3 squared plus 4. And that would be your equation for this parabola. Which is pretty cool because we figured that out just by knowing what the vertex is and the focus. We didn't know anything else, any other points about this parabola, but we were able to come up with this equation. Okay, so let's go ahead and try another one. And this is part C on page 161. And now this time you're given a vertex and a directrix. Okay, so again, I really think it's helpful if you draw a picture. Okay. So let's just go ahead, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so first up, we have a vertex at -2, 1. So -2, 1 is right here. Beautiful. Okay. Then we have our directrix at y equals 4. So remember, y equals 4 means it has to cross through the y-axis at 4. So that's going to be here is your directrix. And remember, a directrix is always a line. Okay. So now if this is our vertex and that's our directrix, and we know that just like in the last one, we know that the parabola always opens towards the focus, but it always opens away from the directrix. So that's going to look like this here. We've got to open the opposite way of the directrix. Again, just a sketch, and you're good to go. Okay. So now we know the vertex. We need to figure out this p value. So remember, your p is the distance from the vertex to the focus or the vertex to the directrix. So if this point is at -2, 1 and this is at 4, then it is 1, 2, 3 units away. Okay. So now we know that our p is equal to 3. Okay. So now again, we're going to plug in here because again, even though it opens downward, we know that it has a vertical axis of symmetry. Okay. The only thing that's different is obviously when it opens downward, we need that negative out front. So let's go ahead. We've got y equals -1 over 4p, which we're going to plug in our p is 3, times x minus h. So here's where we have to be careful because our vertex, remember, is -2, 1. So because it moved to the left 2, this is going to look like x plus 2 squared. And then it moves up 1, so it's going to look like plus 1. So then we just need to simplify, and we have y equals negative, because it opens downward, 1/12, because 4 times 3 is 12, times x plus 2 squared plus 1. And that's it. That's your equation for this parabola. And again, pretty cool because we found that just by knowing what the vertex and the directrix were. Okay. All right, awesome. Let's go ahead and try one more here. And this one is part E on page 161. So this one tells us that it opens up. So as soon as it tells you it opens up or down, you know it's going to have a vertical axis of symmetry. Whoops. So that's why we know, again, we're working with this. Like I said, tomorrow's video will focus on the horizontal axis of symmetry, which is when it's going to open left or right, your parabola. Okay. So this one opens up, so right away we know it's going to be a y equals. It has a focus of 5, 7 and a directrix of y equals 3. Okay, so let's go ahead and draw this. So we have 1, 2, actually, let me go ahead. And so I have some more room, do this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Okay, so our focus is at 5, 7. So 5, 7, that's our focus. And our directrix is at y equals 3. So that's here. So now here's the weird part is that we have our focus, we have our directrix, but we don't have a vertex in this one, okay? But we know that the vertex should be the same distance away from the focus as it is the directrix. So basically what we need to do is we need to find the midpoint between those. So if this one is at 7, the focus, and this is at 3, there's 4 in between them, so we just need to move down 2 and up 2, and that's where your vertex is going to be. Does that make sense? So it's just really the midpoint, or right smack dab in the middle between those, okay? All right, so now let's go ahead and figure out what that vertex point is. Okay, so if that is, if the focus is at 5, 7, then this is going to be at 5, 5. Okay, because this y value, the 5, is right in between 7 and 3, so we're good to go. Okay, so then we just need to figure out, we know that this is going to open up, so this is kind of what the parabola looks like. But really, we just need to figure out, okay, what is this p-value? Which, remember, it's the same distance from the vertex to the focus and the vertex to the directrix. And both of those, remember, should be 2. So now we know that that is our p-value is 2. Okay, so let's go ahead and plug it all into our equation here. Okay, so we've got y equals, it opens up, so we know it's positive. 1 over 4p, and we know the p is now 2. And then we figured out where our vertex is because it had to be right in the middle of the focus and the directrix. So we have that it moved to the right 5, so x minus 5 squared, and up 5, so plus 5. So let's go ahead and simplify, and we get 1 over 8, and then x minus 5 squared plus 5. Okay. And again, pretty cool because we didn't even have the vertex for this one, but just with the focus and the directrix, we could figure out where that vertex is. Okay. Awesome. So that is it for the writing the equation when we have the vertical axis of symmetry. And then tomorrow we'll talk more about when it's horizontal, so when the parabola opens left or right instead. Okay, so if you have any questions on these, be sure to bring them to class tomorrow, and have a good one. Bye-bye.